Okay, Bismillah ar-Rahman ar-Rahim. We'll continue doing problems for this section 7.3. Determine whether the disk washer method or shell method is better for adding the value of the solid by generating this. Okay. Yeah. What I will do, first I need to grab the function. We did it before, it's okay. Now this is the 0. I know if I take x squared, I have 2 minus x. So this is 2. So these are the zeros, it's positive here. This is not cross it, let's touch it, because it's even power. And so do something like this. Yeah, this is just a sketch of the function. And they have y equals 0, which is the x-axis. This is the y-axis. And they want rotation about the x-axis. Okay. Now I need to think about the line. If I make it as a shell method, then it means I need to take the line parallel to the axis of revolution. That is not good, because I need to find this function, I need to find this function in terms of y, which is not easy to do. So the best way to do it is by taking the line perpendicular to the axis of revolution. That means I need disk washer method. And it's very easy. I have r of x will be the function minus 0. Okay. And I have the area will be pi of disk square. Pi times r of x square. So it will be the, and from where to where? From 0 to 2. Very clear, from 0. So volume will be equal pi. It will be pi integral from 0 to 2. Yeah, the formula for the I have pi. And for the shell, I have 2 pi. Huh? Be careful about pi, 2 pi. Okay. So you have pi of this. Then I have the function square. Yes. Now I need to do the calculation. That gives me what? Pi from 0 to 2. Open this. That will be 4x to the power 4. Yeah. Minus 4x to the power 6. Plus, no, minus 4x to the power 5. Yeah. It will be 2 times 2x squared times x cubed, which is 4x to the power 5 plus x to the power 6. X, just a matter of calculation. Now we'll continue. That will be pi integral of what? This will be 4x to the power 5 over 5 minus 4x to the power 6 over 6 plus x to the power 7 over 7. Okay. That give me that from where? From 0 to 1. That from 0 to 2, sorry. So that will be pi of this. 2 to the power 5, 32 times 4. Oh, what a number. Yeah, but you notice something. This is 2 squared, 2 to the power 5. That will be 2 to the power 7. I will leave 2 to the power 7. I'll tell you why. This one I have 2. This is 3. And I have 2 to the power 7 over 3. And this one, I have 2 to the power 7 over 7. Yeah, so that means I can take 2 to the power 7 outside times pi times the rest. Yeah, that will make the calculation easier. So I have 2 to the power 7 times pi times what? This is 15 times 7, which is 105. That's the common denominator. Over 5 is 3 times 7, which is 21. Over 3, which is 5 times 7, which is 35. Over 7 is 15. So that gives me 2 to the power 7 times pi over 105. Yeah, you can get the number now. I don't know. That would be what? 2 to the power 5 is 32. 2 to the power 6, 64. That will be 128 pi over 105. Yeah. Hopefully I'm not missing anything. Should be pi times this into. Okay. Find the volume of the solid generated by revolving the region bounded by this and this about the line x equals 3. Okay, let me graph the regions as usual. That will be y equal x square. That is y equal x square. This one at 0 it's 2. And at -2 it's 0. So this is my line. Okay. That will be my line. This is the parabola and the line is there. Okay. So I'm talking about this region. About the line x equals 3. Yeah, when they equal to each other, I have x square equal x plus 2, point of intersection, I mean. I have x square minus x minus 2 equals 0. So I have x minus 2, x plus 1 equals 0. I have x equal minus 1 or x equal 2. So this is minus 1, and this is 2. And they want my axis of evolution is somewhere here. This is which is 3. This is 2, but this is 3. This is my y-axis of evolution. Okay. So very clear to me. I think washer will be better. So washer will take the line parallel to the axis of revolution. So I think I have everything is very clear. So what I have, h of x will be what? Will be the line minus the parabola. This minus this, okay? What is b of x? B of x, if this is x, I want this distance, which is 3 minus x. So the volume, from where to where? From -1 to 2. This is x minus 1, x equal -1, this is x equal 2. So the volume will be 2 by integral from -1 to 2 of this product, minus x squared plus x plus 2 times 3 minus x dx. Now I need to do the product. See what will happen. I have x cubed. X squared will come from where? I have x times minus x. That will be minus x squared minus 3x squared. That will be minus 4x squared. X will come from where? X times 3, 2 times minus 6. That will be plus x plus 6 dx. Now do the integration. That will give me what? X to the power 4 over 4 minus 4x cubed over 3 x squared over 2 plus 6x. That from where to where? From minus 1 to. Okay. I need to do some calculation now. That give me 2 by 2, give me 16 over 4. That is 4 minus what? 2 cubed times 8 times 4. That will be 32 over 3 plus 2 plus 12 minus. This is minus 1 over 4, or plus 1 over 4, sorry. This is an even power. Plus 4 over 3. It's minus 1 cubed, which is minus 1 times minus 4, 4 over 3. Plus half, minus 6. Okay. So that give me what? 2 by times I have 4, 2, 6, 12, 4 and 6. It's 12 and 12, I mean. 4 plus 2 is 6. 6 plus 12 is 18. I have minus 6. So that will be 24. 18 plus 6 is 24. Okay. Now over 3, I have this with this. Minus 32 over 3. Minus 4 over 3. That give me what? Minus 36 over 3, which is minus 12. Okay. And I have 1 over 4 plus half. That will be 3 over 4. It's minus 3 over 4. Okay. So I have 2 by, do the calculation the way you like. 12 minus 3 over 4. That give me what? 2 by 48 minus 3, which is 45 over 4. So that give me 45 by over 2, which is this one. Good. I get the correct answer. Okay. Now, next one. Now, this seems to be respect to y. Okay. I graph the region as usual. It's good to practice these things. X equal to y squared. This is the parabola. And they have the another parabola. This is the parabola. And the parabola, it's if y equals 0, it's 1. It will do something like this. This is the second parabola. Okay. And what is the axial revolution? Y equal minus 2. This is my axial revolution. Okay. I notice which method is better. If I took the line perpendicular and have here something, there something, so it will be complicated a little bit. So it's better to make the line parallel to the axis of evolution. So I have the shell method. Okay. I need to find these points of intersection. So I equate the two functions, 2y squared equal y squared plus 1. That means y squared equal 1. That means y equal plus or minus 1. So this is 1, this is minus 1. Y values, these are the y values. Okay. Now I need to find h of y, the length of the line, which is this parabola minus this parabola. So I have, now it's ready. I have y squared plus 1 minus 2y squared. This is h of y, which is 1 minus y squared. What is b of y? B of y, the distance, if you consider this is y, the distance up to this, which is y minus 2. So it's y plus 2. Good. Now we have everything ready. So the volume will be 2 by integral from minus 1 to 1 of this. 1 minus y squared, y plus 2, dy. So it will be 2 by minus 1 to 1. I need to do this multiplication. Minus y cubed minus 2y squared plus y plus 2. dy. Yeah, and it is the calculation that will be 2 pi minus y to the power 4 over 4 minus 2y cubed over 3 plus y square over 2 plus 2y from minus 1 to 1. 2 pi minus 1 over 4 plus 2 over, from minus, no, from 1 to minus 1. What is this? That will be minus 1 over 4 minus 2 over 3. Substitute 1 only, plus half, plus 2, minus. Now substitute minus 1. That will be minus 1 over 4. This is will be plus 2 over 3. Is it? Yeah. Okay. And this one will be, oops, plus half, minus 2. That's method calculation. Do it the way you like. Okay. Now half minus 1 over 4 minus 1 over 4. That will be 2 over 4, which is half. That will be half. This one minus this one. What's wrong? I'm sorry, this is 0. It's half. Minus 1 over 4 minus, that will be plus 1 over 4. That will be 0. Who cares? Yeah. Minus 2 over 3 minus 2 over 3. That will be minus 4 over 3. Half minus half. That will be 0 also. 2 minus minus 2. That will be plus 4. Yeah. That will be 2 pi times 4 minus 4 over 3, which is 2 pi 12 minus 4, 8 over 3, which is 16 pi over 3, which is this. Okay. Next one. Yeah, I don't need to be here. Okay. I have a hyperbola. This is hyperbola. I know how to graph it. I have a hyperbola, which is, this is one, this is hyperbola. It will do something here. I don't care about this. And I have, well, this is 1. And I have the line y equal to, this is y equal to, and they want this about the y-axis. Be careful about the y-axis. Okay, I don't need this. Huh? No need to be about. I have this region. I'm talking about this region. Yeah, this is a little bit tricky. So it's the point of intersection. If y equal 2, then I have 4 minus x squared equal to 1. So I have x squared equal 3. So x equal plus or minus square root of 3. So these are minus square root of 3 and square root of 3. Okay. I will do my line. My line will be parallel to the axis of revolution, which is this one. So h of x will be what? Will be 2 minus the function. I need to rewrite the function. What is this? I need to write in terms of x. So this one give me y square equal what? 1 plus x square. So I have y equal plus or minus equal to 1 plus x square. I need the positive one. So I have 2 minus square root 1 plus x square. Now, what is p of x? If this is x, this side, this is will be x. The trick is where? Yeah, which you need to be careful about. Now, the line of revolution is in the middle of the function or of the region. So now if I do rotation about the y-axis, we do rotation for this side about the axis of revolution, I'm getting a volume which is similar if I do the rotation for the other side. So I don't need to write the limit of integration from minus square root of 3 to square root of 3. I need it only from 0 to square root of 3. If you notice, we do the rotation, this one, these things will be covered. So you don't need to rotate both of them. Or the thing is, if you do the rotation, it will give you the volume just if I have from 0 to square root of 3. Yeah, I don't need to do it from minus square root 3 over 3. I hope it's clear. So what will be the volume? It will be 2 pi integral from 0 to square root of 3 of the product of these two functions. 2 minus square root 1 plus x squared times x dx. That give me 2 pi integral 0 square root of 3 to x minus x square root 1 plus x squared dx. Notice I make it from 0 to square root of 3. Okay. Now let me do the calculation. That give me what? The integration now. I have 2 pi x squared. Yeah, here, this is u. If u equal 1 plus x squared, u equal to x dx. So I need 2.5. So it will be minus half. Yeah, square root of u. Look at this. X square root 1 plus x squared dx. That will be what? Take 2.5. So that will be half u to the power half du. That give me half 2 over 3 u to the power 3 over 2 plus 3. So I need half, not half times, I need 1 over 3. I don't need half. 1 over 3 u, which is 1 plus x squared to the power 3 over 2. And that from 0 to square root of 3. Okay. That give me 2 pi. Now substitute. Square root of 3. That will be 3 minus. Here I have 1 plus 3, which is 4, and the square root is 2 cubed. So the minus 8 over 3. 0, that will be 0, but this will not be 0. It will be 1 minus 1 over 3. So that give me 2 pi 3 minus 7 over 3. That gives me 2 pi 9 minus 7, 2 over 3. That gives me 4 pi over 3. Okay. Now we'll go to some old exams questions. We did like the questions which explain the topic. Now we'll do old exams questions. Let me try to make quickly to do the things faster a little bit. I have the graph that will be x squared 1 minus x. We have 0 and 1. Function will do something like this. It will be 0. And this is 1. And it's positive here. Then this touch and go back. Yeah. And y equals 0, which is the x-axis, about the y-axis. Okay. So this will be my line, parallel to the y-axis. Okay. So what is h of x will be the function. B of x will be x. which is just the list as usual. So the axis of motion, P of x will be x. And from where to where? From 0 to 1. So the volume will be 2 pi integral from 0 to 1 x times x squared minus x cubed dx. That will be 2 pi 0 to 1 x cubed minus x to the power 4 dx. That will be 2 pi x to the power 4 over 4 minus x to the power 5 over 5 from 0 to. That's 2 pi 1 over 4 minus 1 over 5. That is 5 minus 4, 2 pi 1 over 20. That gives me pi over 10, which is this. The volume being generated by the volume around the y-axis, the region, the first quadrant, the curve, this. Okay. Around, yeah, from x equal. Okay, so I have x squared, I have 3 minus x. Okay, that will help me to graph the function. So I have what? I have 0 and 3. And for 0, negative value, give me positive, so it will be here. Then it will touch it, then go back, same thing. Then okay. This is what we will do. I have it from 0 to 3. This is, I want it from 0 to 3. And about what? The y-axis. This is the axis. Okay. So do my line like this. I have h of x will be the function. P of x will be x. And the volume will be 2 pi integral from 0 to 3 x times 3x squared minus x cubed dx, which is 2 pi 0 to 3 3x cubed minus x to the power 4 dx, which is this one. Now he did not do the calculation, just he wrote the way the volume is without doing the integration. So he set up the integral, but he did not evaluate it. Okay. Yeah, sometimes we'll have things like that. Okay. Now I have this one. A little bit complicated region. Let me check. I have x equal y minus y squared. I can take minus y squared common factor to see the vertex. That will be minus y. Took minus as a common factor plus 1 over 4 minus 1 over 4 or plus 1 over 4. That will be minus 1 over 4. I need plus, so it's minus y minus half square plus 1 over. I'm just completing the square. Okay. So this is the vertex is 1 over 4 and half. The vertex is 1 over 4 and half. This is just to help me to graph the function. Is the x value? This is x is 1 over 4 and half, and it opens the left and passes through the origin, because 0, 0 is very clear. Okay. I have x equal y minus 1. X equal y minus 1. So if x is 0, y is 1. And by the way, this point is what? When it will when x equals 0, y is 1. So here I have 1. Okay. So this is, it will pass through this. So that's the line. Okay. When they are equal to each other, point of intersection, equate them. That's very clear, y equal plus or minus 1. So that will be minus 1, and that will be 1 for the y values. Okay. Now we are talking about what he wanted where? In the first and second quadrants. First and second quadrant. So he needs only this region. This is the region he needs. Okay. So up to 0. He needs only the things in the first and second quadrant. Only. This is what he said. Okay. So now, oops, let me do my line. The line will be something like this. This is my line. As I said, I'm caring only about these region, first and second quadrant. Okay, so h of x, h of y, it will be in terms of y. What is the axis of revolution? The x-axis. Barrel means, okay, the things in terms of y. H of y will be what? The parabola minus the line. Minus y plus 1. So it's 1 minus y squared. That will be h of y. Okay. And if this is y, what is this distance? It will be y. So b of y will be y. So the volume will be 2 pi from where to where? It's not from minus 1 to 1. It's from 0 to 1 because I need only the first and second quadrant. So it's from 0 to 1. I need the region just in the first and second quadrants. Now h of y times b of y dy. The rest is just calculation. 0 to 1, y minus y cubed dy. That will be 2 pi. I have what? Y squared over 2 minus y to the power 4 over 4 from 0 to 1. That will be 2 pi half minus 1 over 4, which is 1 over 4 times 2 times pi. That will be pi over 2. Okay. The volume that's generated by revolving the region cosine hyperbolic. I know how to graph it. This is cosine hyperbolic. 1 is like the graph. Okay. X equal 0, x equal 1, y equal 0, which is the x-axis. Okay, and x equal 0. So I'm talking about this region. This is the region. And it's about what? About the y-axis. So this is my axis of evolution. So take this parallel to the axis of evolution. Very clear. What will be h of x? Will be the function. What will be p of x? It will be x. X, this distance, which is x. So it will, and from where to where? From 0 to 1. So the volume will be 2 pi from 0 to 1 x cosine hyperbolic x dx. Yeah, I think this is just a gift. In the region bounded by the curves, y equals sine, y equals cosine, and 0 between, okay, we've done this line, then the volume is this. Okay. I have y equals sine x. I need only 2 pi over 4. And I have y equals cosine x. This is pi over 4. And this is 0. Yeah, I don't care about the rest. Only I'm talking about this region. And involved about the line x equal pi, which is this line. This is the x equal pi. Okay. Don't forget, I'm talking about only this region. So I do the line parallel to this, like this. So I have h of x will be what? Cosine minus sine. The upper will be the cosine in this region between 0 and pi over 4. And b of x, be careful, b of x. If this is x, I need this distance, which is pi minus x. So now what, and from where to where? From 0 to pi over 4. So the volume will be 2 pi 0 to pi over 4 v of x by minus x times h of x dx, which is okay. Nice. Okay. Find the volume solid obtained by taking the region bounded by the curves. This. Okay, about the line x equal 1. Let me graph the function first. Y equal 1 minus x squared. So this is 1, and the parabola will go like this. Okay. X equals 0, the y-axis, the x-axis. Okay, and x is positive, so I'm talking about this region. X is positive. He said x is positive. I'm talking about this region. And I wanted about the line x equal 1. So this is my line, x equal 1. So this is 1, this is minus. Okay. Now, what will be h of x? Now we'll do the line. Let me do the line. This will be my line using the shell method, parallel to the axis of evolution. H of x will be 1 minus x squared, the function minus 0. P of x, if this is x, I want this distance, which is 1 minus x. 1 minus x. So the volume will be 2 pi from where to where? I need only this region, so it's from 0 to 1. From 0 to 1. The product of this. Yeah, I need to do the calculation. That will be what? 1 minus x squared plus x cubed dx. That gives me 2 pi. What I have? X minus x squared over 2 minus x cubed over 3 plus x to the power 4 over 4. From 0 to 1. That gives me what? 2 pi 1 minus half minus 1 over 3 plus 1 over 4. That I can make it over 12. I have 12 minus 6 minus 4 plus 3. That give me what? Yeah, 12 to 5. 2 pi times 5 over 12, which is 5 pi over 6. Which is okay. Now he doesn't want the full answer. He wants just the setup of the integral. Okay, let me graph the function as usual. I have y equal x cubed, y equal 1, and x equal 0, which is the y-axis. I'm talking about this region. Okay. And I want it about the line y equal minus 3. This is y equal minus 3. Okay. So I want my line to be parallel to this. Parallel to this, so it will be, this is my model. Oh, so I need the things in terms of y. So I need to change this. That will be x equal y to the power 1 over 3. Okay. So h of y, the things will be in terms of y, will be what? What is the line? What is the length of this? It will be y to the power 1 over 3. V of y, this is y, I want this distance, which is y minus 3, which is y plus 3. From where to where? The y values from 0 to 1. So the volume will be 2 pi 0 to 1 y 3 plus y. This I can write it cubic root of y, the way he wrote it, dy, and that will be my answer, which is easy. Okay. A region divided by the triangle. I have a triangle here. It's involved on the x-axis. Okay. I have a triangle. So it will be 0, 1, 0, 1, 1, 0, 2, 0. So I have this triangle. It's my triangle. Okay. And I want to revolve that about the x-axis. About the x-axis. Okay. Be careful. Now, what will be my line? I want it to be parallel, so it will be this is my line. So I need to know this function and this function. Okay, how to find this function? Let me say in terms of y, huh? I need everything in terms of y. Yeah, that will be, yeah. Let me say f1 of y, this 2, f2 of y. Now for f1, what are the points? I know that the line passes through this point and this point, which is 0, 1, and 2, 0. So it is the slope. The slope will be 0 minus 1 over 2 minus 0, which is minus half. That will be my slope. Okay. Now, the formula for the function will be what? Y minus 0 equal, or I can write it. Yeah, I want one with the x minus 0. Easier. Y minus 1 will be minus half x minus 0. So I need to, don't forget, I need to write in terms of y. So I have times 2. I have 2y minus 2 equal minus x. What does it mean multiply by minus 2? Multiply by minus 2, I have 2 minus 2y equal to x. So that will be f of 1 of y. Good. Now for f of 2 of y, what are the points? I need this line, so I need this point and this point. So I have the points 0, 1, and 1, 0. What will be the slope? It will be 0 minus 1 over 1 minus 0, which is minus 1. That will be my slope. Okay, so the equation, also choose this equation, y minus 1 will be minus x minus 0. That means x will be 1 minus y, which is f2. Okay, now what is h of x? Will be f1 of y minus f2 of y. And that give me what? 2 minus 2y minus 1 plus y. That give me 1 minus y. Okay, and what's p of x? P of x is very clear. It's p of y, I mean, it will be y. Okay, v will be what? 2 pi from where to where? This region from where to where? Y values. I'm talking about the y values. That will be 0 to 1. From 0 to 1, 1 minus y times y dy. Now it's just a matter of calculation. 2 pi 0 to 1, y minus y squared dy. 2 pi y squared over 2 minus y cubed over 3 from 0 to 1. That gives me 2 pi half minus 1 over 3, which is 2 pi 1 over 6 pi over 3, which is this one. Okay. Continue. Use cylindrical shell, the volume of the cell is the region bounded by the 3 curves. I have 3 curves. Okay. I need to graph them. Y equals 0, the x-axis, very clear. Y equals x squared. This is y equals x squared. This is at x equals 0, it is 2. And at x2, I have this line. I have this line. Okay. So I'm talking about which region? Be careful. Now we have different regions. Okay. I want it which is bounded by the three curves. By the three curves. I have y equals 0, which is the x-axis. I have the x-axis. So I'm talking about this region. Yeah. Be careful about the region. Okay. And it's evolving about what? The x-axis. X-axis. Okay. Now this is my region. Now let me put the line. My line will be this. My line. Parallel to I'm doing cylindrical shape method. Parallel to the axis of revolution. Okay. So what will be h of y, huh? In terms of y? Also, I need to write everything in terms of y, not in terms of x. So I have here x equals square root of y, plus or minus. I don't need the plus or minus. I need only the plus since I'm working in the dispositive side. And here I have what? Y minus 2 equal minus x. So I have x equal 2 minus y. Okay. This region, what will be the upper is the line minus the parabola. So it will be 2 minus y minus the square root of y. That will be h of y, the length. And what is b of y? It will be y, since the axis of evolution is the x-axis. So the volume from where to where? I'm talking about the y values. Huh? That will be 0. This is 1. Huh? Their intersection point, x squared minus x plus 2. So I have what? X squared plus x minus 2 equals 0. So I have x plus 2, x minus 1 equals 0. I need x equal 1. If x equal 1, y equal 1. I care about the y values. That will be y equal 1. So my volume, 2 pi from 0 to 1. This y, and this is h of y, dy. That will be my answer. I think we have a good number of examples. Let me stop the recording. Yeah. Yeah. Thank you.